Great. Well, hi, David. Nice to see you.
Hey, good to be here.
Great to have you. So, David is also joining us from
Okay, let me
Japan,
just jump.
and he's with Fujikura Kasei, and he'll
Yep.
be telling us about new EMI shielding solutions for 5G.
Okay, so good afternoon, I think, for everybody. Uh, Evening here. I'm Dave Dewey with Fujikura Kasei's Electronics Materials Division here in Tokyo, Japan. Uh, just to give a quick introduction to Fujikura Kasei, we produce polymer materials for a variety of applications under five main business divisions. So we have our coating division for which makes coatings, hard coats and clear coats for plastics. Then we have our architectural coatings division, which makes paints and coatings for housing and other buildings. And then we have our medical materials division, which makes polymers for medical diagnostics. And then we have our functional polymers and resins division, which makes a variety of materials such as pressure sensitive adhesives and other functional polymer particles. And finally, we have the Electronics Materials Division, which produces dough-tight electrically conductive adhesives, inks, and paints. So dough-tight, as you can see in a brief blurb here, goes back to the 1950s. And we even have a few materials that have been in continuous production since at least the 1960s. So we were among the first companies in the world, and definitely the first in Japan, to produce these kinds of electrically conductive pastes. So our headquarters is in Tokyo with our R&D facilities a bit north in Saitama and our production a bit further north in Tochigi. And then we have a global network, including some subsidiaries in the US and UK. So I always make sure to give a quick explanation of what dough-tight is. Dough-tight is made of four components. First, you have the filler, which is the metallic powder that provides the electrical conductivity. In some cases, it provides electrical insulating properties. Then you have the, oh, it's out of order. I'll just bring all of these up. Then you have the binder, which is the part of the paste that adheres to the substrate, and it binds the filler as a paste. We use different binders for different applications. So epoxy resins for adhesives, silicones for stretchable inks, acrylics for sprayable paints. And then the solvent modifies the viscosity so that determines, how you can apply the material. A higher viscosity would be something like an adhesive that you dispense. Lower viscosity would be something like a paint that you spray. And then something in between would be an ink that you can print. And then you have other additives that enhance different properties of the material. So dough-tight is grouped into three main fields or applications. And we have our adhesives for electronic components. We have our inks for printed electronics. And then we have our paints for EMI shielding. Each type of these materials provides a different properties for different applications, as you can see here. An important point is that all of these materials are for additive processes. You simply apply them to your substrate and cure them, and then there's no extra production steps needed. But today, so I'm going to focus on the EMI shielding. So these shield materials are designed to be used as coatings on plastics and other non-conductive materials to provide a conductive layer, which can allow for weight reduction by changing over from a metallic casing to plastic. It can contribute to miniaturization with component level shielding, and these can open up more complex designs by replacing difficult to apply tapes and sheets with a simple coating that is conformal to the substrate. So I want to start with the very basics of EMI shields today, because when I joined Fujikura Kasei and started exhibiting our dough-tight materials, we put a heavy emphasis on our newest and most novel materials. And as I mentioned, we have some of these materials that go back decades, but we were focusing on the new things like the moldable and stretchable inks, the roll-to-roll inks, the sintering adhesives. And we really just didn't expect people to be interested in these older, simpler EMI shield paints. But one thing I've noticed over the years is that there's always a few people visiting our booths that have just never thought to use a conductive paint this way, you know,